Steve, you get started, okay?
Okay.
I'm going to call out to parent. Stephen, I'll come back, okay? I'll deal with Kirsten first. Kirsten,
Hi.
how about your progress? I just want to know about your progress. How many program you actually you will work recently?
Recently I finished three, and so but I had a question for one of them.
Which one?
This one. I'll send you the link.
Make sure you report every week, okay?
Yeah, sorry, I forgot to screen.
My purpose is not to actually to try my best to help you, because if you don't work on it, then you don't have enough training. You know what I'm saying?
Yeah,
That's the part I want to look at.
yeah.
2016 number three mouse the field. Okay, let's look at it. Okay, I'm sorry. 2016 December number three. Okay, let me share my screen. Okay.
Thanks.
Ki- for Stephen, I'll come back with you later. Okay, because Kirsten will be quick. He's just working on the problem.
Okay.
Let's deal with him first, and he will log out anyway. 2016, number 3, December, bronze, Java, 2015, 16. Let's look at 16 December. Okay, so it's Maori. Okay, let's look at this problem. So there's a Maureen, and Maureen 1. Okay, so this problem look like I work on it twice. The first version is not good, so whenever I have a separate version, that means that I improve later. You know what I'm saying? The
Yeah.
first time I work on it may be working, but not the best one. So usually
Okay.
this kind of problem is harder.
Hmm.
After a while, I think about a different way to do it, and it's become better. So now let's look at this Maureen problem. So the problem is so slow is Farmer Jones' progress on some of the grass mowing might grow back when he finishes his mowing. Any section of the grass that's cut at the time t will appear on t plus 1. So after t plus something, it will come back, okay? So mowing pattern might have him to revisit the same cell multiple times. The same cell may visit multiple times, but he remarked that he never encountered a cell in the grass he's already been cut. So that's actually what happened is he go on to somewhere, cut something, something. So when he cut back to a certain cell, this at least longer than t times, longer than x unit of time, okay? If not longer than x unit of time, when you revisit it, it will actually not grow back because it will reappear at least at t plus x. So determine the maximum possible of the x. So based on a certain pattern, whatever he grow, then you need to know about the time that actually passed right here. This is the x. What is the maximum x? So let's assume that this is a circle. There are several points that you read it a certain time, and then the time that we read it, the maximum time. So let's assume this is 20, 12, this is 8, this is circle is 4. Then you need to use the x of 12 because this one you must grow back before he read it. So that's the problem what they want. Okay, so basically they are endpoints, and then here it actually here has an n line. N line is n line. Okay, it's totally 6 line, and then n line, and then each one of them has a northeast. So this is 6 point showing up the north of 10, east of 2, go north by 10, go east by 2, whatever. This is actually give you the chart of how he do mounting. Okay, and then you need to determine the crossover point for that X. Okay, so basically this problem is a timestamp based simulation. So you basically go from your beginning point, you actually, let's assume you start from 0, 0, and you go north 10. So basically the first point you go over would be north 10, and it will be a time of 10 units. And then you keep calculating the distance before this different point that you have a crossover point to detect the crossover point, and then detect the loop that you have to determine the time. Okay. One moment. Let me pick up my wife is clicking on the door. Let me open for her. Okay. I'll
Okay,
come
okay.
back. I'll be back.
Yeah.
Hello, sorry, actually, now my wife is a trick or treat, so sorry.
Oh.
Okay, whatever. So basically, this is what we will need to do, okay? So you actually do timestamp. So you actually from time one and you do simulation, do each one of them, you recorded your coordinate of each point. And then when there is a crossover in the point that you show up, see how long this one is.
Mm,
So you started from 0, 0, and you go north. So each one unit, you go up, 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 up. So you recorded which point you have already visited. And then once you
mhm.
have a point that you already visited, and then you will actually keep track of them and see how long you visited the point.
Wait, but how do you store the coordinates in an array? Because like there's
You can
two.
store two value. You can store a point or a tuple, or you can do this. You can do the I plus I times 100 plus j. That's one integer you can store, or you spawn a point
Um,
object. So this
okay.
number, if you need to pick a very big one, pick a very big one, or you store a point of x and y. Let's look at the
Okay.
code. Let's look at the code.
Hmm.
So this one, just looking at let me see. So this one actually is a C double plus code. Okay, that's okay. Let's actually open it. Okay, let me see. Let me check. Okay, okay. Now I understand now. So this one actually I use a C double plus code. Let me open the Java
Oh.
version. So I have two versions. I think that the other one I rewrite it by Java. So let me look
Oh.
at Java version first. But I can later give you both versions for your
Hmm.
reference. Okay.
Hmm.
So let me choose the Java version. Now I remember now because it had been a while for me. So this is, let's actually open it. Okay, it's Java version. I think the other version is a C double plus version, so we can talk about it later, okay?
Hmm.
So this one, we do have these. So now you set up the dxdy. So dxdy, you go, dx is x, is east, and then this one is north.
Hmm.
This one is west. So you have four vectors, okay? Four vectors.
Yeah.
Now there's a point. Points of point, you do have the x and y. So you set up this point. This one will be very quick. So we do this very many times. You just need the equals and to string. Is that okay?
Hmm. Yeah.
Okay, so these two, okay. Now let's look at the main program. These two part, we talked about it already. So now next one, you actually create a array list of point and array list of integer.
Mhm.
Okay, so array list of point, I think you will remember the array points. And T list, I think is the timestamp. Okay, T list is timestamp. So now your N is the first one that you read in, right? You have read in the N. And then your minimum set to the negative. So this one is the minimum. You will try to get the minimum number.
Hmm.
So now you have actually starting from 0, 0. So your P0, your initial point is at the XY. Okay, 0, 0, that's no problem. So you add that point to there and you add your timestamp 0 to there. So your time set to 0, and then you will go up to N. N is the timestamp, okay, number of the lines. N is the number of the lines. N is the number of the lines. So you start to read in line by line. So each line, you actually, first you will get a character of direction because it will give you the east, next, north. Okay, so this is direction. So based on your direction, you determine your D value. D value
Mm,
is your direction's index. So 0, 1, 2, 3 for the direction, right?
mm,
And your step is the number of steps you go. So that's actually, you start from 0, 0, you go north 10, so that you will go here. So basically, you based on the step, you change your xy by the number of the dx/dy. Is that okay?
yeah.
And then you create a new point that you will reach a new point. Then you reach a new point. Okay, then you reach a new point. You reach a new point, and then you actually see if the point index of the point already show up in your set, meaning that
Mm-hmm.
have you revisit it or not, right?
Mm, mm,
And then if the index greater equal to 0 means you already get it, then you update your timestamp.
uh-huh.
You put your timestamp into you update your timestamp and calculate the gap. If the gap between the timestamp, you find it, you see the previous visit time. This is your previous visit time, and then your current time minus the previous visit time, you get the gap, and then this gap is the total time you actually travel. If that actually
Um,
is smaller than the minimum, you have to update the minimum.
okay.
And then you set the index, the point with the new time. If not, you add the new time to it. So this one is actually the available list, non-recurring list. Is that
Mm,
okay?
yeah.
Using a non-recurring list too. So this one is T is to keep track of the T is to keep track of all the VDT time. And then after
Mm,
that, you actually, if you never revisit a point, then you set it to -1. It actually no visit. Otherwise, you print out the minimum time that you have.
yeah. Wait, why can't you just like instead of using like another array list for time, can't you just use like the index?
In the array list of time, you using that you need to know about the gap, the previous time and current time.
Oh, okay, okay.
You need that. You not just the index.
Okay.
You need to know about when you cross over next what is the previous time you have and then the current time you read it, then that's the gap you have. That's the
Okay.
minimum loop that you need to travel.
Okay.
Okay?
Yeah.
So I'll send you this Java version, C++ version, and PowerPoint file. Okay?
Yeah. Okay.
Okay, I'll do it later. Bye
Okay.
now.
Thank
Bye
you.
now.
All right.
Bye-bye.
Thank you. Bye.
Okay, Stephen, go back to you. Okay. I finish him first. How about a previous problem? Let me look at previous problem. What do you solve? How do you solve it? Can you explain your algorithm for me?
Um, so I basically realized that if you compare one thing to another and that thing is smaller, you advance the index in that array, and then
Mm-hmm.
you compare it again. And then if the other one is smaller, you add that, and then you advance the next one, and then you keep comparing that. So that's basically it.
How about if they are equal?
If they're equal, you just add one of them and skip it. Add to both indexes.
Okay. Next one. This one is not linear solution. You actually have the 4n square algorithm. It's not linear solution. So why true? Why do you write a for loop that is why true?
Because like
When
for
do
the
you want to break the loop?
I was thinking of breaking it when like both
Then
of
you
them
put
are
then you put in the while condition that when you done with it, you break it. It's a very bad habit. Why do you need to make your BJ to be empty?
Because it's like duplicates. So
Why do
if
you
there's
need
like
to why do you need to know it?
if in like the first array there's like
Why
like
you
two
worry
ends.
about you duplicate? You have the duplication, that's fine. You modify your original data. You're not supposed to do that. You modify your input data. Why take J equals 3?
Because like that means you scan it like the
Hmm?
entire array for one time.
Who say that? Who says it's 3?
Oh wait, oops.
Why J equals B but length -1, you actually I increase. What's the purpose for this one?
Like once you scan the entire thing. Wait.
You entire thing for what? So why you change I to J and then change J to I? What's the purpose for IJ?
It's like once you already found like it exists one time, you just move on to the second index. Like
You move
if
on to the
A,
second integer. Shouldn't you move both I and J?
because I was thinking like here, and then you found it here, and then you just move
Yeah,
it. You
you
don't
move both I and J.
take,
Why you just move I or why you just move J?
shouldn't it like consider like the entire like array?
Hmm?
Because I was thinking it's like this, and then you have to compare if it's inside the entire thing. So if you move it like
You read the
here,
problem carefully. How do you need to compare everyone for everybody? Data is alphabetical order, possibly duplicate, return the count the number of string appear in both arrays. So you just need to see if A show up in both, but A may duplicate. A may duplicate. So what you need to have is that you may have A in and then C in here. You may have A, B, C. So when you have the A, you need the next one go to C. This one you need to A and then go to B. So your current one need to avoid the one that the same with you. So it's not I plus plus.
Oh, okay, okay.
It is the one that you go to the next one that's not equal to yourself. But the data already been sorted. So why do you do this?
Is it to check like if the next
You
one?
update
Oh
your
wait.
eyes and J separately. They don't work together. And if it's wrong, using if you don't solve the problem.
Wait, that means you need like a for loop to count how many times. Right.
You need to have a while loop to count it, yes.
Wait, a while loop or for loop?
While loop and for loop are the same. Why do you asking this problem? We explained it to you before.
Okay.
For loop is a special while loop. So why do you need use for loop?
I think it's like easier to understand.
It's harder to understand.
Oh,
You have an A, you may have A, B. You want to advance this A to B. How do you do it?
count how many times A occurs and then find that amount and
No,
then plus one.
that's wrong.
Oh,
You don't need to count how many times it occurs.
just like use while it is not A.
Yeah, well, it's not A, and then you increase your I.
Okay.
While you plus one, your I may keep increasing. This one, the first thing you need to do is you need to have a string. you pick up your current AI first, and you go for the A array to find the next one that's not equals to, while it's equal, you continue to add. So this one is not equal, this is equal. So while it's equal, you continue to increase your I until you meet someone that actually is not I, or your I equals eta length.
Yeah.
This is to advance your I to the next available I. You need to do the same thing for J. And then
After that, you just check. Wait up.
you don't
Because
need to
now,
check. This is done enough. The if is finished. You do something else.
wait, don't you just keep checking it again?
Check in again, the for loop will do. You have something else to do. So this one, A equals B. So what else you need to do?
It's not A not equals B.
No, you have A less than B and A greater than B. You have two cases. Here you need
Oh.
to else, if, or else. Why do you need to do that?
Because like if it's on like the last index, you can't add more to it. Oh wait, no, because it's in a while loop.
You have one more bug, but that's not there.
Hmm. Wait, is it the while condition? Because like sometimes if it ends early, it doesn't catch all of it.
Sometimes what? It's no problem. Your problem, you don't know what's your problem?
No.
Look at your if. What's wrong with your if? Your three if. What happened to your if? How comes that I say there's some error there? You have A equals to B, A greater than B, A less than B. So what happened if A equals B but contains?
Or you skip it?
You skip it, you still need this while loop, but you don't need to add it. But you didn't add it, you didn't increase your I and J.
Wait, so you said that if mm, okay, so it equals it. Okay, so
Why do you need to do that? You change your original if.
just do or statement.
Why do you need to have an or statement?
So like both if they're in or
It
not in.
doesn't happen that way. It contain or not contain actually means that you actually do nothing.
Okay, so like wait, no. Mm.
So just do equals. When it equals, you will advance both the I, but you will add
Oh,
it only when it's actually not contains.
yeah, okay.
So you totally don't know what you are doing. There's no S. It's not constant, it's contained, it's
Oh,
actually
oops.
S. There's no
Oop.
S. There's S here. Okay, this is one way to do it. It's not the only way to do it. You can use histogram.
Was it like counting it and then it's already
Not
inside?
counting it. This actually using Boolean. This is an easier solution, even though maybe a bit longer in coding, but it actually is easier to understand. You just go through each of the array, and then if there is a A, you mark A to be true. If there is a B, you mark B to be true. If there is a duplicate of A, you will just mark it for once. And then you go through all of the A to Z. If there both A show up and B show up, then you increase your counter. That's it. This is a better solution because this you don't have a while loop inside the for loop. So the one that you are coming up actually is still order n squared algorithm. This one still is an order n squared algorithm. This one is order n algorithm, even though it's a 3n, 3 times of the for loop.
Yeah.
Okay.
Yeah.
We have 2 minutes left. That's it for today. Okay. I don't think you can finish another one. Your problem right now is your planning is still too weak. You don't know what you are doing. Why you are doing that? Because you don't practice enough. Okay. No matter what you are doing, you are not practicing enough. So that's the part you need to work on. Okay. Work on the homework by yourself. Don't copy. Okay.
Okay.
Apparently, you copy too much. I can only tell you that. You can actually keep arguing, but I know that you are copy too much. You look at other people's code too often. That's why you lose your opportunity to learn. Okay, good night then. Bye-bye.
Good night. Thank you.